Okay, my name's Jeremy Andrews. I'll be going over the bridge pattern today. Um, Alright. The motivation for the bridge pattern is to create a disconnect between the abstraction and implementation of classes, which had been standard method was usually to do just use an inheritance. Uh, Unfortunately, when using inheritance between two classes, that binds the abstraction to the implementation permanently, making extension, modification, and reuse difficult. The bridge pattern separates these into separates the abstraction and the implementation by separating them into two different class hierarchies. Uh, these separation into class hierarchies while maintaining connection through a implementation or an imp kind of gives them the bridge and keeps them connected. The intent, as I said, is to decouple the abstraction from its implementation, allows abstract objects to be implemented across multiple platforms, or an abstraction to be implemented across similar applications or similar implementations. It allows a many-to-one relationship between object abstractions and its concrete constructors or implementations. It also allows for one-to-one, obviously, and it can also allow for a one-to-many relationships. Pretty flexible that way. General structure is like this. You have your imp, which basically ties the abstraction to the concrete constructors through the implementer, which is the overall class, overarching class for the concrete constructors. The abstraction also uses the refined abstractions, or is composed of. Applicability, it avoids the permanent binding of abstraction and implementation, allowing for ease of extension, modification, and reuse. Also allows for some isolation in that any changes in the abstraction should not affect the implementation. Same way as any changes in implementation should not change any of the abstraction. Furthermore, with C++, it's can be used in a one-to-one type situation to hide all of the implementation from the client, leaving only the abstract interface visible to the client. And it's also its ability to share the implementation among many objects. Decoupling and implementation as a consequence, as well as improved extensibility and hiding of implementation details from the client. This is the structure of the program that I had modified from one that I found online. That's covered in the references at the end of this, and it's the same program that I'm going to be doing the demonstration on. Implementation can be a degenerative one-to-one case to hide the implementation in C++, and it also allows for the abstraction to select from the group of constructors based on parameters passed to the abstraction. References and source code. Get out of this and go over to a quick demonstration. Very short bit of code here, very short little program. Implementation classes for time, civilian time, and Zulu time, otherwise known as military time. And then abstract classes, time, civilian time, and Zulu time. And then I just hard-coded 2:30 in military time and civilian time in here. And then my Boolean for AM and PM. Set that to true for 2:30 p.m. This takes a minute to come up. And there we have it. 14 hours, 30 minutes since midnight, 2:30 p.m. and 14:30 hours in military time. Alright, again, references are at the end of the slideshow. Bring that up again real quick. Textbook, sourcemaking.com, and a YouTube video on bridge pattern. Thank you very much.